Welcome to the lecture on lipids. Probably not as familiar a sounding structure as some of the other things. Proteins, carbohydrates, you hear a lot about. You actually do know lipids quite a bit. They are often referred to as fats. Okay, so you can keep that in mind. This is sort of a strange group of molecules. Here's a good way to describe them. A group of organic molecules that are grouped together mainly because, I keep having these misspellings, because they're insoluble in water. I often describe them as sort of the odd sock drawer of the macromolecules. You know, you throw the extras in there. They are important. Okay, fat gets a bad name. Certainly the way that people eating a Western diet have sort of maybe gone to the table a few many times. There are some issues with them. Here's what they are. So as I said, they're fats, and you know, gross or not, whether you're vegan or not, that is a good portion of fat right there that you find in red meat. Also found waxes, so you have the wax of the honeycomb there, and then steroids. Steroids, I think they get associated with sports quite a bit, and there's no doubt that there is a problem there. But there are also things like cholesterol, and I guess that actually gets a bad name too. They are important parts of what you are. Another example is hormones, and I'll talk about that in a second. But you have steroid-based hormones. But that's what they are. Okay, fats. We're going to really concentrate mainly on fats that are found in people as we move forward here. So what do? There's some important parts, and they're not all listed here. But one thing is that they're a key component of cell membranes. Remember, if you want to have a cell, you're going to have some sort of barrier, some sort of border, and that is what. So you have all the cell parts in here, and it's a lovely little cell, a little vacuole. Okay. But what is the edge? And it can't just be that everything can come and go as it pleases. You need to regulate movement, and so you need that barrier, plasma membrane or cell membrane. Okay, as I said, hormones such as testosterone and estrogen, and you can see the sterone, so the steroid-based hormones, like that. Okay. And then the last one that I put here is energy storage in the form of fat. This is something called adipose tissue in us. Adipose tissue stores our fat, and we can store up quite a lot of fat. Actually, I've read somewhere that if you got up and started running and were able to keep going and just burn the fat that you have stored, the average person could run something on the order of 1,600 miles or some crazy thing. I probably am not remembering that correctly, but now that plays some other parts here. Our fat is also insulation, so we can say that. And you think about blubber and some of the Arctic animals and Antarctic animals, and that's also cushioning. And I mean, not so much when you sit down or things like that, although I guess that's part of it. But cushioning for your internal organs is provided by some of your fat as well. So that's some of what it does. In terms of the structure, we have to focus on one type here. And we're going to just focus on what's called a triglyceride. Now, I know you guys get a little hesitant when you hear these tricky terms, but so clearly there's three of something because it's tri, and there is a glycerol in it, and that's where that name comes from. So we're going to just look at the structure of a triglyceride. So it does have glycerol and three what are called fatty acids, and so you should get to know that term, fatty acids. And we're going to talk about them somewhat extensively in this. And so this is what a triglyceride looks like. Here's the glycerol right there on the edge. And you can see there's 3 OH groups, 1, 2, 3 OH groups that are just waiting to bond together. Now don't worry about things like ester linkage and stuff like that. A key thing to look at here is that there is this part, which is our glycerol, and then coming off of it are 3 fatty acids. So it's sort of like that. Okay? And in some cases, like in the cell membrane, one of them gets replaced with something else, a phosphate group specifically. But these are our fatty acids. And you can kind of think of what we're doing here as storing up energy. And you can see some variation. Actually, I think these are all kind of the same. But that's it. You have this structure. This right here is our triglyceride. Triglyceride. And it's one form. You saw the complicated form of a steroid hormone, or cholesterol, excuse me, on the first page. And so these come in different forms. This is how you store fat right there. Clearly, on a molecular level, it looks a little bit different. Now, there is another part to this, though. The fatty acids actually can be divided up into saturated and unsaturated fatty acids. Now, think about that for a second. That you've probably, if you've been at all attentive to nutrition or the news or things, you hear things like the fact that saturated fat is not so good for you, and unsaturated or even polyunsaturated fat is good for you. And maybe you can make associations with it. So what kind of fat is saturated fat? And where would you find an unsaturated fat? And here are a couple of examples, and these are just a couple of examples, that you find saturated fats, like there, and those are found in things like butter, red meat, not the protein part, but that white edge to it, often dairy, although that gets a little iffy. One thing about it that you can think of is that saturated fats are often solid at room temperature. And notice that butter stands up. You put a piece of butter there, even, unless it gets really, really too hot, and it stands up. Actually, all that stuff is butter. Or you put a steak on the counter and the white fat doesn't melt away, does it? So those are saturated fats. Over here, we have at least one example of an unsaturated fat, and that's just oil. Okay? Oil is an example of unsaturated fat. Now there's others. Actually, avocado is a good source of unsaturated fat. But this is a good representation of the difference here. And these are liquid at room temperature. And then there's an interesting thing is that, well, what if you didn't want the unhealthy, this is sort of unhealthy, saturated fat, and you would rather have the healthy unsaturated fat. And there's, too much fat of any type is bad for you, but generally speaking, those are how they're categorized. Well, if you don't want butter, but you do want something on your toast, well, maybe you could take this liquid and somehow turn it into a solid, and that's what's called margarine. And it actually turned out, that seemed like such a great idea, but it turned out to be worse for you, and maybe you've even heard of trans fats being even worse for you. And I'm not going to get into why they're worse for you. Maybe you can go ahead and look that up, but they're even worse than saturated fats. Now, in terms of the structure here, this is what they look like. Okay? And what you have here, now we're not dealing with the glycerol part, just a saturated or unsaturated fatty acid. And I want to be real specific here. So let's look at the saturated fatty acid first. That what you would have are carbon molecules. Okay? And I'm not even going to worry about the end here. There'd be an OH and stuff like that. Okay? The carbon molecules would be surrounded by hydrogen. Now I'm just going to draw a couple of them like this. And then we usually just represent them as dashes. So all these dashes represent hydrogen bonded to it. Okay? And the question is, in this portion here, where could I put more hydrogen if it's all surrounded all over? And the answer is nowhere. There's no more room. There's no more room for hydrogen. Okay? And that's said to be saturated. Saturated means you couldn't put any more of something in it. If a towel's saturated, you can't soak up any more liquid. Now over here, and I'll switch colors just to make it a little clearer. Again, I have carbon atoms, but the difference is that somewhere along the way I have a double bond. And again, we have our OH down here. This is our fatty acid. Now, remember, carbon can have 4 bonds, so that's hydrogen surrounding that one, and that's hydrogen surrounding that one. That's 1, 2, 3, 4. Now this already has 1, 2, 3, so I can only put one more. And same thing here, one more there, and then finish it out. And so as I look at that, could I put any more hydrogen? And the answer is actually yes. If I could get rid of this bond, I could put another hydrogen and a hydrogen. So there is room. We just have to break a double bond, and then we could add hydrogen. This is mono unsaturated. And you could probably guess what polyunsaturated is, where I would have something like this. We'll just do it like that. And again, our OH down here, don't worry about that. And I start putting my hydrogens around, and look, I have to, oh, see, I added one too many. This one, come on, this one actually already has 4 bonds to it, so it gets no more, and then that can be there. And so there's a couple of places now that I could break that bond, and I could break that bond, and I could break that bond, and put in all these molecules. Now, so this is polyunsaturated. Polyunsaturated fat. Saturated, sorry. Okay? Now, if you come back up here and remember the solid versus the liquid, this explains why, actually. The saturated fats are straight, and they line up, and they can compact and be really close together. One of the properties of solids. You can get everything packed tightly together. Over here, because of the bending, you have these molecules separated. And so since they're a little bit looser, they end up being liquid. And obviously, if you had a polyunsaturated, you'd have multiple bends, and it'd be, well, it wouldn't be more liquid, but it'd be liquid. Okay? So that's the differences here in our fats and our fatty acids. So keep that in mind. Sorry, I just like to make sure I got nothing else coming. As you go forward, that lipids play an important role. And do remember that triglyceride, we can alter that and form things. Eventually, we can form something that looks like this, a phospholipid. We won't worry about what that is, but it's got a couple of fatty acid tails here, and those are our fatty acids. So that's coming in the coming weeks, so just keep an eye on that. Okay, so that's it for lipids. Please bring to me any questions you may have. We're rounding out our organic molecules here, and everything is there and available for you. But please, if there's any question at all, bring it to me. All right, great. I'll talk to you later.